These are the Lesson 5.3 notes on transforming parabolas. Today you'll graph a parabola in vertex form. You'll take a graph of a parabola and try to write an equation from it, and you will convert between what's called standard form and vertex form of a parabola. More on that in a little bit. To graph a parabola in vertex form, we're going to use our calculators to kind of get an idea of what these graphs look like. A reminder is that we will type our equations in the y equals menu. I want to use a nice window. I'm going to use -10 to 10. You can get that quickly by hitting the zoom button and pressing the number 6. And we're also going to take advantage of our table feature to find points, which we can access by hitting second graph, and we can see some actual values that your graph goes through. If your table doesn't look like this table, you can hit second window and just make sure that your table, I usually like to start my table at 0. Make this number a 1 right here. That means the numbers will go up by 1. Make sure that these both say auto. If you go to second graph, you'll see our table starts at 0. The x values go up by 1s. You can also press the up arrow to see some negative values. On our first graph, you're going to notice some points here. They include things like -2, 4, -1, 1, and 0, 0. So I'm going to take some of the values that I see over here, and I'm going to graph them over on this first graph over here. So I see a point at -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. This is a pretty common parabola that we worked with a lot in math. This is our standard y equals x squared graph. On our second equation, it says y equals x plus 2 squared minus 1. So same kind of thing. We're going to do x plus 2 squared minus 1 on my calculator. Graph it to kind of see that this graph has been moved left and down. You can see the vertex appears to be left 2 and down 1 from where it originally was. To verify this, you can hit second graph again. And I see values like -4, 3 on my graph, so I'm going to graph -4, 3. I also see values at -3, 0, -2, -1, that is our vertex, -1, 0, and 0, 3. This is enough idea to kind of get an idea of what this graph looks like. We have another parabola that kind of does something like this. Our third graph has y minus 1 squared plus 2, so I'm going to change in my parentheses here this to a -1 squared, and on the outside to a plus 2. We're going to graph this function. It appears that our graph has been moved right and up. It looks like this vertex is kind of right 1 and up 2. I'm going to go to my table and just see some points here. It looks like we have points at things like -1, 6. Right there. 0, 3, 1, 2. This is 2, 3, and 3, 6. So it looks like our vertex has been moved right 1 and up 2. And you'll notice we have numbers 1 and 2 in our equation. That does have something to do with where your vertex is at. Continuing to see what we have for our other graphs here, we have 3 more graphs. We have a graph that has a 2 out in front. This is 2 parentheses x minus 1 squared plus 2. Kind of like the last equation, we just have a 2 out in front. Kind of resembles the graph we just did. To see if there's any difference, we'll go to second graph. And I notice this graph has a point at 0, 4. So I'm going to put a point here at 0, 4. 1, 2, 2, 4. The other points are up at 10, so this is about as much as I can do with this here. If you compare this graph with our last graph, you'll notice same vertex location. They're both at 1, 2, but this graph seems to rise up a little bit quicker than this graph does. More on that in a little bit. Our last equation, we have y equals, we're going to throw -3 out in front, x plus 2 squared minus 1. The graph has a kind of an upside down feel to it. Looks like it's been moved left 2 and down 1 from the vertex. To get some points, we'll go back to our table one last time here. I don't have a lot of points I can work with, but I do see -3, -4. I see -2, -1, and -1, -4. And our graph does something like this. Now I asked you to graph this without a calculator using some information you saw here, and similar to what we saw with our work with absolute value functions, in parentheses if you see x plus 2, your graph moves left 2. If you see x minus 1, your graph moves right 1. So inside the parentheses, a plus sign means you're going to have a left movement, and a minus sign means you're going to have a right movement. The minus on the outside tells you how far up or down your graph has been moved. This vertex is down 1 unit from 0, so that's why you kind of see this minus 1. If you have a minus on the outside, it's going to be down. If you see a plus on the outside, your graph is going to be moved up from 0, 0. The number on the outside is kind of like the slope, and you can kind of think of these first few problems. There's no number on the outside. It's kind of like there's a 1 right there. So if you start at the vertex and move 1 space to the right, the graph goes up 1. Same thing for this third graph right here. It's kind of like a 1 right here. So if you start at the vertex, if you move 1 space to the right, the graph moves up 1. On this fourth graph, where there's a 2 right here, if you're at the vertex and move 1 space to the right, the graph goes up 2. It's kind of a similar idea to how slope worked. And in this problem, if you start at the vertex and move 1 space to the right, you go down 3, and that's what this number is. So it's kind of like the slope. It's not exactly the slope, but it's kind of the same idea. And it just applies from the origin, from the vertex to the first point to the right. So if you're graphing this without a calculator, the x plus 3, it's a plus on the inside, so you're going to move your graph left 3, 1, 2, 3. The minus 5 means we're going to move down 5, 1, 2, 3, 4, 5. Here's our vertex. And then the 4 means if you move 1 space to the right, we're going to go up 1, 2, 3, 4. Now the graph is not going to continue to go up by 4s, but at least to the first point, to both the right and the left, it will go up 4. And that's really all you need in order to be able to draw a decent looking parabola. So what do these different things mean if we're working in vertex form? This value inside the parentheses refers to kind of your horizontal shift. You can think of h as being horizontal. And if we see a minus sign inside the parentheses, our graph is going to move right. If we see a plus inside the parentheses, your graph is moving left. The k, I think it would make more sense if they called it a v, is referring to the vertical shift of your graph. Negative values on the outside means your graph is going to move down. Positive values on the outside means your graph is moving up. And the a is kind of like your slope. It just refers to the distance vertically from the vertex 1 space to the right. So whatever number that is, that tells you how far vertically you're moving from the vertex to 1 space away. And it applies both to the right and left. I've been saying to the right, but if you're at the vertex here, you move 1 space to the right, the graph goes down 3. That's what that minus 3 meant. On this graph here, if you're at the vertex, you move 1 space to the right or the left, you're going to go up 4. So that number tells you how far vertically you're traveling. So in coming up with equations on the backside of your worksheet for these parabolas in vertex form, we're going to use this vertex form that I'm kind of circling right here. All of your answers should look kind of like this. So that means all of these problems will start with y equals. Y equals. Here's your vertex. To get from A to B, it looks like the graph is moving up 2 units, so we're going to put a 2 here. If we start at 0, the vertex of this graph has not been moved left or right. So you can put just x, or you could do like x minus 0. I would just do x squared. We're not moving it left or right. But if we start at 0, 0, this vertex has been moved down 1, so we put a minus 1 at the end. On our second graph, we're going to start with y equals. Here's your vertex. To get from C to D, we're going to go, as we move 1 space to the right, we have to go down 1. So I'm going to write negative 1. If we start at 0, 0, the vertex has been moved 1 space to the right. Remember, if we move 1 space to the right, we write x minus 1. That means 1 space to the right. It's an x squared graph because it's a parabola. And the vertex has been moved up 1, 2, 3, 4 spaces. So up 4 means we're going to do plus 4. On this last problem, same idea. We start with y equals. From the vertex to the first point, we have to go down 1, 2, 3 units. So we're going to write minus 3. the vertex, if we start at 0, 0, we had to move 5 units to the right to get to where the vertex is at. So 5 to the right means x minus 5. And this graph has moved up 5 units as well, so we do a plus 5 at the end. Earlier this week, we talked about standard form of a parabola, which is y equals ax squared plus bx plus c. Usually we have numbers where these squares are. Vertex form is what we just wrote, and we have numbers where the a, h, and k are. How do you get back and forth between forms? For example, if you have y equals negative 2x squared plus 8x plus 3, how do you get this in vertex form? Well, what we're going to do is we're going to replace, first of all, the a with, well, the a. So this is the a value in this problem. It's negative 2. That's just going to go right out in front. So that's pretty easy. Whatever a is just kind of goes right there. H, we're going to use the formula which we used the other day, negative b over 2a. So what we're going to do is we're going to take b, which is positive 8, but we're going to make it the opposite of that. So the opposite of positive 8 is negative 8 over 2 times a, which was negative 2. And if you crunch out 8, or negative 8 divided by our denominator, which is 2 times negative 2, or negative 4, when you divide negative 8 by negative 4, you get 2. That's your h value, and that goes here. To find k, we substitute this value into the standard form equation. So what we're going to do is we're going to take this 2, and we're going to plug it into this little expression right here. That's going to be what k is. So to find k, I'm going to plug it into this little formula right here. So it's negative 2 times that x, but we're going to replace the x's with 2's. 2 squared plus 8 times 2 plus 3. The quickest way to do this, get your calculator out. We're just going to type this all in at one time and get a value for k, which is 11. And that goes right here. Pretty easy. Now what about if you're trying to get something like this into standard form? What if we're trying to get this into ax squared plus bx plus c form? Well, we're going to kind of follow the order of operations, which means we're going to take this expression here, and the first thing we're going to do is we're going to work with our exponents. And in this problem we have negative 2. If you have x plus 3 squared, when you square something, it means you multiply it by itself. So we're going to multiply x plus 3 by itself. The next thing we're going to do in this problem is we're going to actually distribute. We're going to do what's called kind of this FOIL process, which means we're going to multiply everything in the first set of parentheses by everything in the second set of parentheses. We're going to leave the negative 2 out front. X times x is x squared. X times positive 3 is positive 3x. I'm going to multiply this 3 times the x and the 3 times the 3. 3 times x is 3x again. 3 times 3 is 9. And we're going to stick that plus 4 at the end. We're going to distribute, which means we're going to multiply everything through by negative 2 inside that set of parentheses. Negative 2 times x squared. Negative 2 times 3x. Negative 2 times 3x again, that's negative 6x. Negative 2 times 9 is negative 18, with a plus 4 at the end. The last step we need to do is add our like terms together, so we're going to add the negative 6x and the negative 6x, that's negative 12x. Negative 18 plus 4 is negative 14, and that gives us our answer, which is y equals negative 2x squared plus negative 12x, or minus 12x, plus a negative 14, or just minus 14.